Okay, so we are going to evaluate some definite integrals here. So I am going to take the integral. So I have x squared minus 2. Square root of x can be thought of as x to the power of 1 half. So I'll have x to the power of 3 halves over 3 halves, and then between the limits 0 to 1. So this can be written again if you want, like so. So then I substitute my upper limit is 1 minus the lower limit, like this. So this becomes 1 half minus 2/3. Okay, so that is 3 minus 4, negative 1/6. That is my answer. Now, as far as this is how you evaluate using the fundamental theorem of calculus, and then you can sketch and shade, right? Okay. You can always use Desmos to graph and see how the graph looks like. So this is a rough sketch of how the graph might look like, and this is the shaded region. Okay. So the same thing, the graph might look like this on Desmos. You can always use that. Now I'm just going to use the fundamental theorem of calculus to evaluate this integral. So the antiderivative of 1 is just x. 1 over x squared can be thought of as x to the power of negative 2. So that means I'll have x to the power of negative 1 over negative 1. Okay. So this can be rewritten as x plus 1 over x. And then I evaluate. I put the upper limit first minus the lower limit. And you see how these two are going to cancel each other out. And I end up with an net area of 0. Okay, going to evaluate a few definite integrals here. So please follow the steps. Okay, so the first thing, apply the power rule. So I have 3x cubed over 3 plus 2x squared over 2. Then I simplify, which is x cubed plus x squared between these two limits. Apply the upper limit first minus the lower limit. So this is 8 plus 4 is 12, and that's my answer. Again, this one, add 1, that gives me negative 1/4 over negative 1/4, okay, which can be written as negative 4 over x to the power of 1/4. Apply the upper limit. I have 16 to the power of 1/4 minus negative 4 over 1 to the power of 1/4. So 16 to the power of 1/4. So 2, 4, 8, 16. So this is 2. So negative 4 over 2 is negative 2. And this is minus of minus 4 is plus 4. So the net area will be 2. So here I will have, I have 2 cosine x. So that means this is 2 sine x evaluated between 0 and pi over 4. So 2 sine pi over 4 is 2 times root 2 over root 2 minus 2 times 0 is 0. So my net area here is root 2, or the value of the definite integral is root 2. Okay, this one I'm going to split up like so. 2 over root t plus 1 dt. And then this can be written as 2t to the power of negative half plus 1. Then I take the integral. I will have 2 times t to the power of 1 half over half plus t between the limits 4 and 9. Okay, so this can be written as 4 times t to the power of 1 half plus t, right? Then I evaluate the limit. Square root of 9 is 3. 4 times 3 is 12. 12, okay, let me do this. So 9 square root is 3. 4 times 3 is 12. 12 plus 9 minus 4, square root of 4 is 2. 4 times 2 is 8. 8 plus 4. Evaluate this. You'll have 21 minus 12, and that is 9. Okay, now this one is sine x is negative cosine x plus sine x evaluated between 0 and pi over 4. So negative cosine pi over 4 is negative root 2 over 2 plus sine pi over 4 is root 2 over 2 minus cosine 0 is 1, sine 0 is 0. So that means my final answer is 1. Okay, here distribute first. So I have t times t squared minus 6t plus 8 dt. And then I distribute it to get t cubed minus 6t squared plus 8t dt between the limits 0 and 4. Then I evaluate it. I have 4 cubed minus 6 times 4 squared plus 8 times 4 is my upper limit, minus 0 is my lower. 4 cubed, 4, 16, 64. So I have 64 minus 16 times 6, that is 96, plus 8 times 4 is 32. So that is a 0. Secant squared is tan theta between 0 to pi over 4. Tan pi over 4 is 1, tan 0 is 0. So the answer is 1. So this can be rewritten as 3w to the power of negative 2. So then I will have 3 times this. So that gives me, this can be rewritten like so. So then I have negative 3 halves minus negative 3, right? So this is negative 3 halves plus 3. So that is 3 halves. So this is cube root of y, can be written as y to the power of 1/3. So this is y to the power of 4/3 over 4/3. Right? Okay, so 3/4, 4 to the power of 4/3 minus 3/4, 1 to the power of 4/3. Oh no, it's not 4, it's 8. Okay, so that's what I was wondering. Okay, so this is 8. Okay, so then what is the cube root of 8 is 2. 2 to the power of 4 is 16. So I have 3/4 16 minus 3/4. So this is going to be 4. So that is 12 minus 3/4, which is 48, 45 over 4. Right? Okay. Next, I'm going to rewrite this, split it up like so. So this can be rewritten as x to the power of 1/2 minus 2 times x to the power of negative 1/2 dx. So then I take this antiderivative. I have x to the power of 3/2 over 3/2 minus 2x to the power of 1/2 over 1/2 between the limits 1 to 4. Now this can be written as 2/3 x to the power of 3/2 minus 4x to the power of 1/2. Apply the limits. You have 2/3 4 to the power of 3/2 minus 4 4 to the power of 1/2, all minus 2 minus 4. So 4 square root of 4 is 2, 2 cubed is 8. So 16 over 3 minus, so, so this is what, 8. 32 minus of negative 2 is plus 2, right? So negative 32 plus 2 is 30. So you have 16 over 3 plus 30. So that is 90/106 over 3. No, it's a negative. Sorry. Okay, let me rewrite this. So basically I have 16 over 3 minus 30, not plus 30. So that is 90 minus 16. 90 minus 16 is 74. Okay. So negative 74 over 3. Okay, so this one is nothing but secant x between 0 and pi over 3. What is secant pi over 3? It's 1 over cosine pi over 3. Cosine pi over 3 is 1 half. 1 over 1 half is 2. And secant 0 is 1. So 2 minus 1 is 1. Cotangent squared plus 1. So cotangent squared, so we had to use an identity here. So if you see sine squared plus cosine squared is 1. So if I divide by sine, I'll get 1 plus cotangent squared is cosecant squared. So this can be rewritten as cosecant squared x. Okay, so then this antiderivative of cosecant squared is negative cotangent x. So then you do this negative cotangent 3 pi over 4. So 3 pi over 4, 3 pi over 4 is in the second quadrant. So cotangent is going to be negative 1, right? So negative 1. So you have negative of negative 1 minus negative 1 because cotangent pi over 4 is positive 1. So you have 1 plus 1, which is 2 as your answer. Cosecant cotangent will be negative cosecant x between pi over 4 and pi over 2. Okay, so negative cosecant pi over 2. So pi over 2, sine pi over 2 is 1. So that is a negative 1 minus cosecant pi over 4. Sine pi over 4 is root 2 over 2. Cosecant pi over 4 will be root 2. So this is minus of minus root 2. So you have negative 1 plus square root of 2 as your answer. Find the area of the region bounded by the graph x-axis and the interval. Okay, so this graph is going to be something like this. 2 to 4 is shaded somewhere here, right? So this is approximately where we want. So I'm going to just use the set up the integral like so. So what you're asked to find is from 2 to 4 x squared minus 25 dx. So that is the area that they want us to find out. So which is x cubed over 3 minus 25x between the limits 2 to 4. Evaluate it. So you have 4 cubed over 3 minus 25 times 4 is 100 minus 2 cubed. So 8 thirds minus 50. So let's simplify this. 4 cubed is 64 over 3 minus 100 minus 8 thirds plus 50. So 64 minus 8 is 56. So I have 56 over 3 minus 50, right? So this is 150. 150 minus 56 is 94. Okay. Yeah. Okay. So this is my answer. Why am I getting a negative? Oh, it's a negative 25, not positive 25. So my graph was wrong. So let me fix that. So x squared minus 25. I took it as negative x squared plus 25. That was why my graph was wrong. So x squared minus 25 is like this. Okay, so negative 5 and 5 are here. So that's why it is negative, because your entire area is below the x-axis. Okay. Okay, sin x. So we are asked to set up the integral. So to find the area, so the area that they are asking you is between negative pi over 4 to 3 pi over 4 sin x dx, right? So how is my sine function? My sine function is like this. Negative pi over 4 is somewhere here, right? Positive 3 pi over 4 is, this is 3 pi over 4, 3 pi over 4. So 3 pi over 4 is somewhere here. So this is the area that we are asked to find, right? Okay, so then I'm going to take this. So negative cosine x between negative pi over 4 and 3 pi over 4, which is negative cosine 3 pi over 4 minus negative cosine negative pi over 4. So cosine 3 pi over 4. Cosine 3 pi over 4 is in the second quadrant. Cosine is negative. Negative root 2 over 2. So that becomes root 2 over 2 minus cosine pi over 4 is positive root 2 over 2. So this is going to be negative, right? Cosine, this is, okay, negative root 2 over 2. So that is root 2 is your overall area. Net area is root 2.